Coming up next on This Week in Radio Tech, it's the episode I've been promising you for literally a couple of months now. Dan McQuillin is with us. He's the managing director at Broadcast Bionics, and that means a lot of cool inventions. And the latest invention is Virtual Rack. Virtual Rack simplifies something that's actually pretty complex, but something that we need as engineers. It's coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, worry-free transmission you can count on with outstanding control, reliability, efficiencies, and Nautel's unmatched 24/7 customer support. Online at nautel.com. And by MaxConnect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. I'm Kirk Harnack, and delighted to have you here. A lot of folks are taking vacation right now. It's the 4th of July holiday in the U.S., and this year, the 4th of July fell on Tuesday. And that means a lot of folks took Monday off, and some other folks took Wednesday, Thursday, and Friday off. But we're here, and glad that you are as well. It's episode 651. Of This Week in Radio Tech. We've been going on strong for, I guess, about 14 years now. I need to count that up and see exactly how long we've been doing this show. Not that it matters a lot. We're doing it week after week, and glad that you're here. Okay, Chris Tarr normally would be here as well. He is on his way into a studio right now, so he'll be joining us sometime during the show. And that just means that our guests will have to repeat everything you said at the beginning of the show so that Chris can get caught up. So I'm in the Telos Alliance studio in Nashville, Tennessee. My employer, Telos Alliance, gives me a little time off on Thursdays to do this show. And Chris Tarr will be joining us from some radio studio or somewhere in Wisconsin. So let's go ahead and check out our guest. Our guest is here from England, from the United Kingdom, England. It is Dan McQuillin with Broadcast Bionics. Dan, welcome in. Good to see you.
Great to see you. And now I know why I'm on this week, because I guess we're the only people not celebrating the 4th of July. We're still bitter. It's only been 246 years, but, your democracy is yet young. I sense some growing pains, but in another 1,000 years, you'll be just as dysfunctional as we are. So yes, happy birthday, or whatever we say. Well done, well played, and yes, you'll be back, as they say in Hamilton. So yes,
if 1,000 years from now we're as dysfunctional as you are in England, well, that'll be good for us, because you guys are not so dysfunctional. You're okay.
I think we are both divided nations politically, but that's fine. Yeah. That's a different podcast, I think. Right? Yeah.
As usual, we will just muddle through. Muddle seems to be the operative word for so many things. We'll muddle through. Although some things are really kind of clean, crisp, new, and exciting, and that's what we're going to talk about today. We're going to get to Dan shortly. He's here from Broadcast Bionics. His title says Managing Director. And, in terms of United States titles, Managing Director doesn't sound very impressive, but in other parts of the world, it actually is. And Dan's the founder of Broadcast Bionics, and he's the intellectual. He's the guy that says, we're going to do this project, and can you guys do it? And when they say, oh, I don't know, he's, well, here's how I think you should. So Dan's going to be talking to us about something called Virtual Rack, which is a technology that makes something that's kind of difficult a lot easier, because they've done the hard work. So we're going to check that out. It's applicable to radio stations around the world, and I'm going to be really excited to understand this. First, though, I need to let you know our show is brought to you in part by Nautel, the transmitter guys, and Nautel does this thing called the Roundtable Discussion. It's Transmission Talk Tuesday, and it's not a webinar per se. It's a roundtable discussion, and they have another one coming up July the 18th. So now's a good time for you to go register for that. If you go to nautel.com/webinars and then click on Transmission Talk Tuesdays, then you can see where you can click to sign up for the July 18th edition of Transmission Talk Tuesdays. What are they talking about? The topic is combiners and filters. And you know what? Combiners and filters are a real mystery to a lot of us. I mean, I've installed a couple of them, and I've certainly been pleasure to be in some amazing transmitter sites that had, a whole room full of combiners and filters. But I don't know much about how they work. So you're going to find out a lot about that along with me on Tuesday, July 18, as Nautel puts on this webinar. Jeff Welton is your host as usual, and you're going to learn a lot. And I love the fact that Nautel is bringing all these technology discussions to us as broadcast engineers, and we can learn a lot. I'm reminded that you do get a half-point credit toward your SBE recertification for attending the Nautel webinars. Check that out, nautel.com/webinars and Transmission Talk Tuesday, combiners and filters. All right. Thanks, Nautel, for sponsoring This Week in Radio Tech. All right, we're going to jump right back in here with Dan McQuillin, and I'm going to ask that Suncast, our producer, keep us informed when Chris Tarr signs in so that we can have a whole new set of questions from Chris Tarr. Dan, this technology, I've been talking about virtualization actually for years, and you and I have had a few discussions about that in the past. And then, lo and behold, along came this technology. My employer, Telos Alliance, made me aware of this thing called containers or Docker containers, and I thought, oh, okay, here's just a way to install some software. Turns out Docker containers, when you get some networking involved and security involved, they can be a little complicated. And I know that my employer, Telos Alliance, even sells service. We will install for money, we'll install and configure your containers for you at your broadcast facility or a hosted service like Amazon Web Services. And this is I believe absolutely the right way to do it. It's the standard way. Everybody in IT or a lot of people know about Docker containers and how they work. They're very reliable. They're portable. They're automatable. And yet, I don't think I could do it myself. I got to get my own guys in support to install containers for me here at my office and coming up at my radio stations in Oxford, Mississippi. But you, Dan, have a little different vision about how containerized software can work. So why don't I turn it over to you to tell us about what your vision has been and is now?
Yeah, so this is a technology podcast, but a lot of what we're going to talk about from our perspective here is as much philosophy and strategy about how we communicate the idea of this technology, which, as you say, has tremendous advantages. This is using industry standard containers and IT standard solutions to help us solve broadcast problems. So broadcasters need to be more agile in how they build facilities. We used to build studios to last 10 years to do one thing. Now we have to be agile and do a different thing one weekend and then in a month's time and flex and scope and all that sort of stuff just to scale our facilities. So there are industry standard IT solutions to that, and that's great. There are a couple of problems with that. And we, alongside Telos Alliance, have been working on this container technology for a number of years. And for a while, there have been fantastic folk like you, Kirk, going out and doing Container University and educating people on what containers are. And people became what we call container curious, which is saying, okay, love it, we'd love to try containers. And then people really struggled and got themselves into a number of problems because it turns out that there, as well as some benefits to containers, are some challenges. So we came up with all of these wonderful advantages that the industry says. We have this flexibility, you can do resilience, so you can fail over from one device to another. You can really build a single 2U or 4U server that can do the same work as a whole rack of broadcast equipment, so you can save energy, you can save space, all that sort of stuff. Easy to flex and manage and ramp up and ramp down through a web browser. And less important perhaps in late 2023, but over the last couple of years where we've seen supply chain difficulties, there's a real benefit to being able to use generic hardware that's available at scale. So that's the fabulous stuff. Where are the problems? Where are the bodies buried? Well, there are a bunch of them. First of all, in order to do this at low latency, you need to do this really on bare metal Linux, and that comes with a whole bunch of complexity for people who are used to working in Windows or even vSphere or ESXi or regular kind of environments. Here we have to get down and dirty at the OS level, and most people don't really want to be down at that command line. Then you actually have to make sure ideally you use Intel, not AMD CPUs. AMD CPUs are very efficient in terms of the number of cores that they offer, but that comes with some trade-offs, which with the very low latencies and consistent latencies we need come with some complications. And then you have to know all about Docker, and if you want to use high uptime, you need to know about Docker and Swarm. You need a registry account with Quay to actually do it. And as Kirk was saying, you need to know an awful lot about networking and all of this specific stuff, all of these new words, all of these concepts that come from the IT part of our companies. And then if we take our broadcast container requirements and try to map them on top of our enterprise container or virtualization environments, we could often find that, in fact, the very things that make our enterprise IT work at scale, which is done as an average to have really good throughput and really good resilience, but isn't optimized for latency, we can't go to our regular enterprise IT people and say, could you just take the whole enterprise's server network down? I just need to change some BIOS settings, and then I need to kind of optimize and do all of our broadcast stuff. So we thought, well, how do we understand the challenges that we face trying to make this work just internally here, and just in R&D, and then with the first few customers, etc., because there were really too many parameters, essentially, for this to really work reliably at scale in the wild. So we came up with two ideas, and one of these is just confounding and bizarre for us as Bionics, because the first thing we did is we say, I think we actually need to offer people an appliance. So just as the likes of Telos are getting out of hardware, Bionics, who've never made or sold hardware, said, no, we actually think that when it comes to the initial implementation of broadcast specific low latency containers, there is a benefit to us offering a piece of optimized hardware which takes that Linux operating system pre-installed on the right silicon with the right BIOS optimizations, with the right version of Linux, with it having the right patches and the right code on it, and a bit like a Mac, right? Most of us have an iPhone in our pocket, or we have a Mac on our desk somewhere, and we're not Linux experts because we don't have to be, because the hardware and the software was designed to work together, and you never actually see all the semicolons that you need to make Linux work when you install a Mac or use your iPhone. So we thought, why don't we actually make all of that hard stuff disappear behind the software interface, and we'll come on to that. But we also thought, why don't we tilt the odds in our favor? So instead of 1,000 different hardware, software, and OS and firmware parameters that you have to get right by yourself every time for every machine you buy, and every customer has to learn that for themselves, often the hard way, why don't we actually simply pre-bake that into the cake, and what you get is an appliance which is either pre-approved or pre-tested with the right combination. So that's an important part of the offer. But then the second part of it was to say, let's actually offer this not as containers at all. Let's not really talk about containers. Let's not talk about Docker. Let's actually talk about what customers are trying to do, which is to build a virtual rack of broadcast equipment. And having made the hardware element guaranteed to work out of the box by being the right hardware, let's build a software element, which is just a browser-based UI, which means you never see a command line, you never see Linux, you never even talk about Docker or Portainer or orchestration or all of that stuff. What you see is a virtual rack of broadcast equipment. So you don't need to know anything at all about containers. You don't need to know anything about Linux. You don't need to sign up for a Quay or a repository account. You never really need to know what a MACVLAN is versus a bridge versus all the different networking complications. And what we offer you is a library of applications. Under the hood, they are OSC standard containers, but we just call them applications, which you can rapidly and flexibly install inside your appliance. And then we offer inside that backup or basic backup and resilience capabilities. And we also did a few things to make it easier to understand actually how you scale, because different applications running inside your appliances or servers use a different number of cores, a different amount of memory, and there's kind of complicated formulas that you need to know to make that work reliably. So what we wanted to offer was a virtual rack, which is as simple to use as a regular physical rack. It's a certain size. We call them application units, so that we don't ship you a server that says it's 16U high, and then you leave a 16U space for a server that's physically only 2U high, but internally has space for 16 applications. So we're giving you that idea of saying, no, what you're getting is a virtual rack that's 16 rack units high, and into that you can put 16 one rack unit high applications, or you could put four rack unit high or application unit high applications. Now, they are actually behind the hood, they're using containers and Docker in much the same way that Axia's Livewire is using multicast. We just don't talk about it. we let the switch handle that, and you talk about live wire channel numbers and discovery. So we said, why don't we, if you like, productize containers, which are this technology? And so you've done a great job with Container University, explain to people kind of how containers work or what they actually do. But then we thought, yeah, but we don't actually day to day, do we need to know all of that and get our hands dirty and all of that? Why don't we wrap all of that in some hardware, which is going to make it easier to make sure that everything will work when you need it to, and some software that means you can orchestrate and manage this just using really simple broadcast kind of friendly paradigms and metaphors. So you just think, yeah, okay, I don't have a server with a certain amount of CPU space and a file that if I edit this file and put a semicolon in the wrong place, this whole thing will just stop. I simply install this appliance, I turn it on, I plug it into my network, I go to my web browser, and in front of me, I see a virtual rack of broadcast equipment. And when I want to add something to the rack, I just add it from the library. And when I want to remove something, I can simply remove it. So as much a philosophy of how we communicate about containers, where we say we want to leverage the benefits of them while actually simply handling the complexity of it inside the software. When I'm being ruder about it, I say we've just monetized the tiers of our R&D department. Every time our R&D department say this is really hard, I'm like, yes, this is great because it makes the product better. Because actually people are really struggling to do this. It's also a product which we've almost offering to the industry that we hope will become obsolete. I really, really hope that as we work with more and more providers of containers, that they will standardize on certain technologies and certain methodologies of us invoking them and starting them up in their little YAML files that you need to sort of roll to get them to spin. All of that stuff is handled for you in Virtual Rack, but we are actually working with the industry to try to make sure that everything we've learned by having to deal with that complexity is passed back to the manufacturers of the containers that we're working with, so that over time, it might take 2 years, it might take 5 years, the technology that we built is designed to be replaced by people's own understanding fully coming up to speed, standardization coming up to speed. And then it could be that other value we've added, and we'll talk about that in a minute, inside Virtual Rack as technology, will be so valuable that Virtual Rack will continue to exist as a technology to help to wrap these things. Or all the licensed applications that you've purchased inside Virtual Rack, because it's not an app store, it's just an appliance that hosts these containers applications, can be passed to your own hardware, to your own data center, or indeed, the migration path is ultimately up into the cloud. So that's the kind of the why.
Yeah.
And
by the way, I'm coming up with some parallels in my mind. Maybe you remember the days of Heathkit, and you could buy a color television kit and put it together. Or you could, of course, go to many stores and buy a TV all put together. And maybe in the earliest radios, receivers, people built themselves, crystal radios at home. And I kind of see this as a proper and normal. What you're doing is a proper normal offering or bifurcation of the way that people can get this done. You can do that. You can do this the hard way, and many people do, which is kind of the IT standard way, or you can also do it the way that your company's come up with. And I like that we want to monetize the tiers, TEARS, of the R&D department. R&D says, this is hard. And you say, good, okay, we can make it easy for people. We'll do the hard stuff and we'll sell the ease of getting it done. Am I about right with that?
Yeah, absolutely. I mean, there are a lot of people out there who are fanatical about Linux and extremely experienced at Linux, and they would be more than capable probably of doing this for themselves. However, I often get the feeling that Linux is less of a product and more of a hobby. And the thing is that a lot of people in the broadcast radio industry are kind of busy just doing their day job. And they're not really looking for a hobby. They're looking for a solution to a problem.
Yes.
And we have that. We have the technology here to do that. It's just it comes with all this extra, not cost really, but complexity and risk. And if you're not confident with the technology, particularly one which is in a broadcast critical part of the plant, then that's you're really going to be fearful then about actually using its benefits. And once you get it working, people are like, yeah, don't touch it. I don't know quite what made it work, so it's just magic. Just leave it. So yeah, I don't want to be rude about Linux or Docker containers, because clearly lots of people use them very successfully, but they are a little bit more complicated when we have to do them at the sort of few nanoseconds of kind of latency that we can support to get real-time, very low latency audio running through them. And once you get down to that, which is that mixture of hardware, software, firmware configuration, and so on, then unless you're really willing for this to be a more or less full-time research and hobby kind of task, it may be better to just let somebody else sell you a television, that's already assembled. It's great that there are people. I'm old enough to remember when computers were sold in kits, and it was great that I grew up with that technology well enough to understand technology from the ground up. And I think if I was born now or had been born a few years ago, I'd be a fantastic computer user, but I wouldn't really understand the real nuts and bolts of how these things work, because they're just so sophisticated and so slick that you just are just used to them working. So I think, we're in the growing pains of this technology in part, but also I think we need to mature the way that we present this technology to end users and consider that we shouldn't necessarily be exposing how these things work. We should be simply making the benefits of containerization available to all. And that will involve some people rolling it themselves, some people having an IT department doing it. Telos have a fantastic professional services group who will help larger customers who need the most complex installations where it has to be customized to their environment. So we'll talk when we show you. I'll give you a run through Virtual Rack in a minute, and we'll talk about what it does. And then we also need to say what it doesn't do, because just like an Apple Mac, it's designed to do a bunch of things really, really well, and it's optimized for that. But then in order to make it simple, we have to not let it do absolutely everything that you might want to do at the most complex end of really, really super large or super complex or super specific networks, because adding that would make it complex for everybody else to manage. And so therefore there is absolutely a space for really, really small single or small container footprint stuff just below what Virtual Rack does, and all the professional services and very IT specific stuff well above what Virtual Rack does. But we felt certainly a year ago when we started really talking to the market about this, that maybe only 5-10% of the broadcast market were really ready for containers at that point. And so we wanted to extend that to sort of 50%. And then I think as the 5-10% becomes higher at that level, then hopefully we will chase the tail around back the other direction, and just really help a wider range of broadcasters be able to adopt all the benefits of this technology really as soon as possible, because I think there's some really, really cool stuff that you can do, and you can let somebody else worry about some of the details.
We are talking to Dan McQuillin. He's the managing director of Broadcast Bionics in England. And thank Dan for staying up late in England to bring us this message and this understanding. As we go through the show, we're going to have Dan give us a demo of what he's talking about, a virtual rack. And then as long as we don't run out of time, I'd like for Dan to go a little bit deeper into describing some of the difficulties, like what is difficult about MACVLAN, or what is MACVLAN. I've dealt with this a bit myself with my colleagues at Telos, and all I know is it's a little bit complicated. And there are other complications too that apparently Virtual Rack solves. We're going to see that, but I'd also like Dan, if we have time, to explain some of those toward the end. It's This Week in Radio Tech, show 651. I'm Kirk Harnack. Dan McQuillin, managing director of Broadcast Bionics, is along with us as well. And Chris Tarr, I promise he's going to be joining us. He is setting up right now, getting ready to join us from somewhere, some mystery radio station. I'm excited about what Dan is doing, because it seems like this virtual rack may be a very good solution for a real sweet spot in the size of clusters of radio stations. I mean, I'm part owner of stations that anywhere from 1 to 6 stations under one roof. And we have several locations with 3 stations here, or maybe we could consolidate, 10 of them together into one operation. And I'm excited about putting, that kind of getting the sophistication of virtualization with the ease of installation and maintenance of virtual rack. So we'll be covering that as things move on. We're actually going to hear a message from Dan's company, Broadcast Bionics, and we'll be right back in just a minute.
Camera One from Broadcast Bionics. Designed to bring video to your audio content, visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot, and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the ATEM. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec ADAM GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
Dan has people standing by to take your call or your email from Broadcast Bionics at bionics.co.uk. Thanks, Dan, for sponsoring This Week in Radio Tech. Oh, you're here. He's our guest. Imagine that.
Yeah, we can give you a quick update. So we hope at IBC to show we're working on integrating the Rodecaster into Camera One. So we know a lot of people use the Rodecaster as a little mini mixer. We thought, there's lots of people out there with Rodecaster for their audio and A10 Mini for their video. So now you can put Camera One between probably the two most popular appliances that we're seeing at the edge. So we have that in the lab here. IBC's in September. So yeah, we hope that we were just planning where we're going to put the Rodecaster on our stand this afternoon. So yeah, come and see us at IBC or talk to BGS or one of our dealers over here. Yeah, if you're interested in Camera One for small scale radio studios, but coming soon to literally to podcasting, via the two most popular, small broadcast pieces of equipment.
And plenty of radio studios, well, they'll have Axia infrastructure back at the main studio, but they'll have talent working from home that may well have a Rodecaster. Maybe the talent does other things as well. And this will give those talent a means to implement an inexpensive, as your ad says, a thrifty way to implement cameras into their shows. So that sounds pretty cool. I'm glad you're integrating that into the Rodecaster Pro. Cool. All right, Dan, I'm excited to see a demo here of what Virtual Rack can do. I saw this at NAB, but, as usual, things are rushed. So I'm looking forward to just taking a deep breath and watching as you explain what this is and how it works.
Yeah, so we've talked about this idea of turning containers into something where the containers disappear and what you see is a virtual rack of broadcast equipment. So hopefully if I press these buttons here, you can see this really is my web browser, and you can see in there we're running Virtual Rack, and we have three Telos containers. We have a Forza, which is an audio processor, an Altus, which is a software mixer, and a Zephyr, which is an audio codec, a multi-channel audio codec set down the bottom there. So these are lit up green, which means that they're running and they're in a healthy state. And on each of those items in my virtual rack, you can see I have two buttons. I have a button for getting to the web interface of the application itself. So there really is my Forza. If I click on that, and then if I click on the Altus, there really is the web interface for the Altus, which doesn't show me much until I click this button here. And so that really is a little software thing with some audio coming from our network in the building here coming across it. So I have three containers spinning up in here, but again, we've tried to move away from containers and MACVLANs and all that parlance, because this is it. When you turn your appliance on, this is what you see. You just see an empty virtual rack, and then at the top left, you see this button that says Application Library. So you press that button. This is an application library, not an application store, because we don't sell you the applications. You buy them from your regular Telos dealer or whoever else licenses the application. So we simply allow you to install unlicensed free trials of each of these things onto your virtual rack, and then you buy the application from your regular dealer. So it's an application library, not an application store, but it is basically an app store like you have on your phone, but for radio stations. So instead of Angry Birds, you can drop down a list here, and you can say, okay, let's install another Forza, because we're going to put an audio processor in here. I'm going to call it F2 in there. So all I have to do is to give it a name. I then select a network that I want to put it on. So I can have multiple networks, or MACVLANs as you would call them, but we'll show you how you set those up in here. And not a command line or a semicolon in sight, Kirk, which is great. So then I hit install. Application name needs to be longer than 3 characters. Okay, I failed the first hurdle. Okay, so I hit install, and that's it. There at the bottom of my rack, I now have in blue, because it's still installing a Forza. Now, if you've ever tried to install a containerized application, you realize it normally takes a little bit longer than 3 or 4 seconds. And it takes me here to click on the App Store and say, I want a Forza. And in case you don't believe me, if I hit web interface, there really is the Forza that we just installed that didn't exist.
Wow.
So now, So now in my rack, I have all of that stuff kind of up and spinning. If I click Manage Application in here, I can see that this has been up for 21 seconds. It's started. It's only using 1.7% of its CPU. So I have to say, your friends and colleagues at the TELUS Alliance make some incredibly efficient code that runs really superbly well in these containerized environments using very small numbers of cores and CPUs. And when we compare that with some of the containers that come from traditional software companies, I have to say, like Bionics and others, where we're just used to using super powerful, large number of cores, then it's some really impressive tech from TELUS behind the scenes here. But in here, I can start and stop the container. I can also look under this little setting here for resilience. And if I press Add Backup down the bottom, that will now create a snapshot of that application with all of its settings and everything to install it or reinstall it. And then I can either, if I make changes to it, I can revert to that simply by pressing the little orange button, and that will just roll back to a previous snapshot of all the config for that item. So now we're taking the physical boxes that existed, we're virtualizing them into our virtual rack, but now we're beginning to see some of the benefits of having done that. We can spin things up and down, so we can reuse that capacity to do something else. So I could go down here and I could go to Manage Application. I could stop my audio processor that I made because I was doing some event this weekend, and now I can get rid of that, and now that's gone. I could say, okay, well, I've got that capacity back. So this is an 8 application unit appliance. I have 1 application unit left. So let's go into here and let's make a VXS. Now I'm going to make a talk show system. If I could type on my keyboard, I'm going to make a talk show system here. And again, on talk show system here, you see I can actually add 2 networks if I want to. So I can have a local network for audio over IP, and then 2 networks for my WAN connections for my SIP. I don't really need all that on here, so I'll just install that. And now again, you'll see that talk show system down there is popping up in blue. Takes it 30, 40 seconds to install it and start it, but then we'll have a VXS running in the virtual rack. So we just took the CPU resource that a second ago was a Forza, and now we have a VXS running in our virtual rack. So I didn't have to understand really much about networking to do that. I didn't really have to understand anything other than I have 8 application units of space. We're actually using all 8 down the bottom. So the Forza is using 1, the Altus is using 2, I think. The talk show is using 1, and the Zephyr is using 4. So that's our 8 application units of capacity, and this is the smallest of the appliances that we use. This is an 8 AU appliance. Now, if I go back into here and I stop that one, and then let's remove it again. Now, you'll notice that when I added it before, there was an extra option that I didn't click on. So I'm going to go into here and let's make a let's make a VXS again. Just call it Talk 2 this time. But down here, I select my network. That's fine. It automatically gives me an IP address that's valid on the range that I've programmed. We'll show you we do that in a minute. But you'll see there's an option down here in the middle which says No Replication. So what I can do when I install this, if I have paired my appliance with another one, so up here you can see that there's a pairing code, and under resilience, I can then pair with a second or with more virtual rack appliances. Then once I've paired those together, then this is marked down here as the primary for this VXS. But if I go to manage it under resilience, then I could add a mirror to that, and then that becomes a secondary to it. So in the event that we detect that this primary virtual virtual rack application has stopped unexpectedly. So if you stop it manually through the interface, it will go, okay, I guess you deliberately stopped me. But if you pull the network cable out, or you pull the power out, or it crashes, then the second appliance is constantly monitoring the first appliance. And if it detects that fails within about 10 seconds, this is not, 2022-7, this is just, a hot spare where it says, oh, okay, I've detected that something's gone wrong with the primary. It will then spin up an identical VXS on the same IP address, and it will have copied across every minute. It copies the config from the primary to the secondary, so that it'll have the latest config in it for when it spins up. So again, we're looking at different ways that we can leverage the benefits of containerization, but to wrap that in this very simple application model where you treat them as applications from an app store or an app library that you're just plugging into slots in your virtualized broadcast rack. And everything else that might be complex to set up behind that happens either automatically or really, really easily. So yeah, we can talk in more detail about MACVLANs and stuff in a minute, but this is where you go and configure it. So you can see down here, all 8 of my application units are busy. That's why they're red and they're allocated. I've got buttons down the bottom to restart it, to shut it down, etc. I can give it a nice name, so when I manage it across the network, I can see my different racks and jump between them. I can see the management port there and this pairing code with a nice copy button to copy that. And then under networking, you get just a nice human readable interface. So anyone can click on this. We have 2 network ports on this device. I just click on it. I give it an IP address, a subnet, and a default gateway. I can even, actually, this is something that one of the Telos guys that we were showing this to early on came up with. I can give it a human readable label, so I can say this is my LAN, or this is my WAN, or this is my AOIP network. So when we're talking about our networks, you can just say, yeah, okay, the person who set it up said, yeah, use this for WAN, use this for LAN, use this for our AOIP. And then down the bottom there, that's where you add those IP ranges. So you can say what ranges do we want actually to auto allocate from. So again, when the user actually comes to use it, you can limit them to only certain IP ranges, or make the whole thing available, or have it auto suggest things. So really all you have to do is go into here, set up the network cards just as you would in Windows, or it's no command lines or semicolons. You just go in here and give it the it comes out of the box with the default IP address that we tell you what it is. You go to that, you give it, you reset the password, you put in this IP address, and as long as you can do that, you can now use full multi-application, containerized, orchestrated, broadcast, resilient technology as easily as you would point and shoot anything in a web browser.
For folks who may be a little bit new to the technology of putting all this broadcast gear into a server appliance, there's no XLR connectors on this appliance. There's no BNC connectors on this appliance. Everything in and out of the appliance is in the Ethernet world. So what are some of the ways of getting audio in and out of this appliance? SIP would be one for phone calls.
Yeah, so SIP is something like the VXS engine, which is doing telephony, has 2 types of connectivity that it's doing. SIP to either your local PABX or a cloud-based SIP provider, and then AOIP, in the case of obviously Telos Alliance, we're talking Livewire. And each of the applications we were showing you there, if it's an audio processor, it can connect to a Livewire channel to pick up your audio input. If it's the VX, then it's taking SIP over RTP from your WAN or from your office network, and it's generating AOIP onto your broadcast network natively, and the same with things like Zephyr, the audio codec, etc. So all of those items are, as you say, all carried across the network. So there's really, at its simplest, when you get a virtual rack appliance, you plug power into one hole, or 2 actually, because they all have hot swappable power supplies, and then you plug 1 or 2 network connections in. Typically, one for your AOIP network, and one for either your office network or your WAN if you're connecting something out. But that's it. As you say, there's no other connectivity, because the software is communicating through the host operating system, which is running Linux. You just never see it, and then that is providing. Is sharing those network cards and resources through to the applications which sit on top of that host operating system. And we'll talk later, if you like, about just how that differs a little bit from classic virtual machine technology, where you have one host operating system, and then you actually host virtualized operating systems entirely on top of that, with some of the cost and complexity of licensing those operating systems and running separate service packs, etc. Here, there really is only one host operating system. That's one of the big differences with containers. There's a host, small Linux operating system running inside the virtual rack appliance. And that is actually running our software, which is monitoring and managing virtual rack. So there's the software that you see, which is the virtual rack interface. There's also a separate invisible piece of technology behind that called the technician, which is actually monitoring and managing and allowing updates and detecting if anything has gone wrong with virtual rack, and meaning it can self-heal and do all that sort of technology. So there's actually almost a piece of AI hidden behind the scenes running in that host OS, just making sure everything is okay. And we even have a really minimal console application, which means you can't ever get to the command line or actually do anything into that Linux appliance. But there is a console you can get to that shows you the IP addresses of those ports, of those cards, and also gives you the ability to reset the database or reset the machine or kind of flatten it and start again as an absolute get out of jail free. Somebody comes in and sets up the IP addresses all wrong and you just don't know where they are. You can actually plug a screen and a keyboard in the back of the box, get that information and either know it or reset it and bring yourself back. So we've tried to make something that you never need to go the whole hog all the way down to logging into Linux or seeing it. You can really manage it, whatever's happened to the box or whatever you do to it in a really simple way.
I got a couple of quick questions before we take our next break, Dan. There are other protocols that are going to become available to go into this. For example, it's not available right now, but Forza, the audio processor right now, is intended for streaming processing and for DAB or for HD processing, anything that's going to be coded. There's an FM version in the works. I don't know when that'll be released, but when it does get released, you'll be able to come out of it as micro MPX. So you can come out of that over IP and go to your transmitter site, micro MPX, and decode that back into analog baseband at the transmitter site. And other protocols are coming too. So I wanted to say that it's not, we're not locked into what you see are available now. Dan, I swear when I was at NAB, I thought there might be some other applications available, not from Telos Alliance, but some other ones. And you mentioned other manufacturers are also working to be in this realm of containerized software. What other things can you tell us about that could be available now or soon?
So commercially available today, we have containers from Telos, which are the Forza audio processor, the VXS talk show system, the Altus software mixer, and I'm probably forgetting one. But anyway, they're the ones that we're shipping now and have working within the product. We're working with Wide Orbit on their playout system, which is also available containerized. We're working with Xperi on Rapid, which is a piece of technology that people use, for their what other people in the US call visual radio. We call visual radio the video stuff, but actually album art and the metadata that goes alongside stuff for HD and online experiences. We're talking to Sound 4 about some mic processing, and we're talking to some folk about some broadcast delay and other sorts of technologies. So I hope by the end of the year we will have a complete broadcast stack. So Virtual Rack is a technology from Broadcast Bionics. It will have a lot of our own products in it very soon, and it will have a lot of Telos Alliance products because we are the Telos Alliance dealer in the UK, and we work very closely as an R&D partner with Telos. But it's not Telos' intention or Bionics' intention that this will be a closed ecosystem. Just like we wouldn't want to have custom cage nuts or rack screws on a physical rack, we want this to be kind of a gift to the industry where we have designed this technology to work very well. We test any application that we put in Virtual Rack. So any version we make available, we handle and manage the update of applications. So if I go into here and I look at something like the talk show system, if I go to manage application in here, I can actually see whether this is the latest version of that software. And when I go to install an application, we've got no space left, but if I think on the VXS, we should have, then I can actually see that I can have multiple versions of that software. And in here, I can actually manage, which versions are available, which are downloaded to my machine, and update, upgrade or downgrade to different versions, and get, so we're helping to manage that technology. But we are testing before we make a version available inside Virtual Rack. We will actually be testing it here on a reference system to make sure that the manufacturers only have to have us test their technology once. And then as we roll that out alongside not just the Virtual Rack appliance, but all of the other applications that we support, that we can make sure that we catch any compatibility issues or problems when we roll out an update. So yes, we want to have a number of application vendors and a completely open system where we'll allow any manufacturer to come in. A bit like any app store, is all we do is we test the applications to make sure that we can scale them properly, so we can actually measure and say, oh yes, this will take 1 application unit or 2 application units, and we can then make sure the virtual rack is able to orchestrate spinning them up and down. This is one of the things we'll talk about later in the show, is actually different containers or applications store stuff in slightly different ways inside the image that they keep for their own storage, and they might need different parameters passed in order to make them work with the networking, etc. So we have to make sure at the moment that each application that we onboard has all those parameters set, that it's tested, and then each time it does an update, we'll be doing that testing here. And there's a cloud-based technology that sits behind Virtual Rack, where each Virtual Rack connects either permanently, or if you want to air gap them just periodically when you synchronize, to that cloud-based server, which then allows them to see which are now the new approved versions of each application that you're permitted, and then it will download those and store them on the local virtual rack. So this way you can install Virtual Rack as a container host completely air-gapped from the internet. And then when you install one of these containers, it will use the locally cached copy, allowing you to actually keep these things securely air-gapped in the way that a lot of broadcasters still want their broadcast networks to be. And then you only have to bring it online when you actually want to update one of those containers or update the virtual rack software itself.
This is so cool. Wow. Dan, this is just amazing. We're going to take our next break. Chris Tarr has joined us, and let's welcome him in right now. Chris, hello. Good to see you. You there?
Hello there. Can you hear me?
I can. Not sure what mic you're on, but yeah.
Okay. Well, it's on my headphones. I had to run. Okay. I'm in beautiful Reedsburg, Wisconsin today, so I just had to grab what I had in my bag here. Out here doing some work this morning. So, yeah, good to find. Unfortunately, I wasn't able to join earlier on, but obviously I stepped in at a great time. Got some great conversation going on here.
Well, the demo has been amazing. We're going to get a few more tech details, but right now we're going to talk about Innovonics. And I know that Chris Tarr has an Innovonics Aaron product. I wish I would have gotten these for my stations years ago. Oh my goodness, it would have solved so many problems. Suncast is going to show us a screen here in just a second of an Aaron 650. This is at one of my towns, one of my station clusters in Cleveland, Mississippi. And amazingly, with a big honking antenna on our STL tower, we can pick up almost every station we have in the Mississippi Delta area. And remotely, I can listen to over the air the over-the-air signal from all of these stations, except maybe one once in a while is not always happy, but it's on the backside of the antenna and there's an interfering station coming in. But it also lets me look at the RDS data. And that's something that our stations, with the leadership of Larry Fuss, that's something that we've really worked hard to implement. The radio text, the PS field, and the call sign, of course, the PI code. We've worked hard to implement that on every single one of our stations so that the injection level's good, the data's updated. Larry has been working with our automation provider, Playout One, so that even during talk shows on our talk stations, we can update the name of the show. We can, and even during long form music shows where they play several songs, we can get the song title updated. We're working on that system. It's an external system that actually recognizes the song and artist and it injects that back in for us. So many cool options with RDS, and for our stations that we're going to implement HD, we'll have all this information on it too. But man, I tell you what, if it wasn't for this is the Aaron 650. This one doesn't do HD. Chris, tell me about what Aaron products you've got in your station clusters.
Actually, the Aaron product was produced as a rebroadcast receiver for translators.
Yes.
It so happens that I have one of these that I was using in a translator that I'm now using in the same way you are. But some of those features are you can create separate RDS for the translator. You can do all kinds of neat little things with that. For monitoring HD, I use the Innovonics the Inno Mini line, and they have, basically the interface is exactly the same. It's got all the same bells and whistles, just in a much smaller form factor, and that's meant for streaming radio stations. And they've got an HD model that I use at my HD sites where I can monitor HD 1 and 2. I can monitor PSD. I can monitor the quality level, all those different parameters on that one receiver. So, yeah, the ARID is great if you're not using one for a rebroadcast. It works great for those. And then again, their Inno Mini line has that same software, but it's just a smaller form factor,
Yeah.
and that's meant for doing the site streaming. But they both kind of have the same software. Great products. I have one of the tuners in every one of my markets, so that from home I can monitor all of my stations.
Oh man, so smart. I wish I'd have gotten that a lot sooner. And of all things, I didn't have to convince the guy with the checkbook, Larry Fuss, to buy this. He convinced himself. And you know what convinced him, Chris? Got so tired of not being able to get good information from our employees as to whether a station was on the air or not. And
Yep.
that can be a problem.
Well, it's funny because I just happened again to have the Justin sitting there at a site where we used to do a rebroadcast translator, and now it's an HT2 one, so it's direct fed. So we had this sitting there, and I wired it up for this. And again, once the station owner heard it, he's like, "We got to get one of these in every market so that we can hear everything that's going on." And that's what we did. Yeah. And it's been great. For example, I virtualized all of our RDS servers and things onto one server. And, so setting all of that up just to have the confidence monitor to log in and make sure that RDS is working right and it's doing what it's supposed to do. All of those, and it has an email alarm so it can email you if it loses any of that. Great boxes. I recommend them highly.
Absolutely. And I thank the folks at Broadcasters General Store for, representing the Innovonics line, all the Innovonics products. There are a lot of them. You may have trouble choosing which one is the right one for you. Go to bgs.cc, bgs.cc, Broadcasters General Store, and they will have, they'll get the sharp pencil out and they'll get you a good price on any of the Innovonics products. So thanks to Innovonics, thanks to Broadcasters General Store for sponsoring This Week in Radio Tech. All right, Chris, you already know him. You love him. It's Dan McQuillin. He's here with us. And Dan, I forget where you were going to go with your next part of your topic. I've learned so much in the last, 45, 50 minutes or so. What would you like to take us through next, Dan?
No, it's really to sort of then explain, where we're going to go next with this sort of technology. So what we've talked about today was what we call virtual rack in its first incarnation, and that's been demonstrated now at a couple of trade shows and is commercially available. But that's only the first of two incarnations that we really see offering this out at. So there will be an appliance involved in the first two incarnations of virtual rack. That's the wrong screen. Hold on. So the virtual rack itself is that self-managed appliance. So we or our dealers around the world sell you either a Dell or a Supermicro or one of these appliances, which has got exactly the right chipsets, firmware, BIOS, optimization, all that stuff. It's got pre-installed on it and pre-configured the virtual rack. So you just plug in power in two nozzles, network in one or two nozzles, and away you go. We hope from late this year or early next year also to offer managed rack. So that is something which your dealer can sell you, but then they will manage for you. So if you've got a really, really simple or small or remote location, then that just needs to be connected into the internet, your local network and power, and that can be completely remotely managed for you. So for small stations, they could be managed, and you can then potentially rent or host the appliance for somebody, and then they can rent the services as well. So we see that as being a new deployment model, so kind of for running into next year. And then we want to take those further as we go into 2024 with what we call cloud rack and hosted rack. And these are a little bit further down the roadmap, but the idea is that rather than an appliance, these are actually cloud hosted. And again, a cloud rack would be self-managed and a hosted rack would be in the cloud, but fully managed as a service by a service provider. So there we're seeing that we can take this technology not just as a stopgap to say how are people able to use containerized or software solutions now, but those same licenses that you're purchasing today to run inside an appliance can be migrated from that to your own hardware or silicon or up into the cloud later. So you're not locked into virtual rack and you're not locked into on-premise, but you're able to make a move, because I think quite a lot of people want to start using software technology, but they're not actually ready to make the leap immediately into the cloud. There are cost reasons for that being challenging for some if you are running services 24/7. There are some latency challenges and some uptime challenges if you're trying to hit very high uptimes at very low latency with the cloud. So this lets people have managed solutions on-premise or easy to manage solutions on-premise today that deliver all of the benefits while having that migration path to eventually putting all this stuff in the cloud, in the very near future.
Wow. Okay. That's a lot to think about. Hey, I wonder if if you might walk us back into the weeds a little bit on some of the problems that, as someone who myself hasn't installed containerized software, at least from I've run a few scripts that my colleagues at Telos Alliance wrote for me, and they work okay as long as the environment is exactly what's expected. Anything's not expected, the script doesn't work. So I've done that a bit myself, but I still got stumbled. I know I brought up MACVLAN before. What is that? What are some of the real technical sticky points? And you had a slide where you just mentioned the name of them, but why are there some real sticky points in putting together a virtualized system using containerized software? What are some of the tough points?
So the sticky points are that these sticky points have nothing to do with the mission that you're on. So if you're a broadcast engineer, these are all abstract or arbitrary concepts, but they can really bite you in the backside. And one of the problems is that a lot of people, it takes them 6 or 7 swings at the ball to get their first container working, and they're like, yes, I've got it. And so they then try that last swing, and they realize that something critical they did on the 3rd swing actually helped the 6th swing to work, but they can't, so it's actually really difficult to do that consistently. And as you said, it starts with the hardware. The scripts work great, but only if you have exactly the right chipset. So tilt it in your favor. You want to use the server-grade Xeon kind of Intel chipsets. It's much harder to use AMD. They're tempting because it's cheaper to buy multi-core and AMD, but the way that the memory, the CUDA cores are allocated across those can create some latency, which means that they are brilliant for average throughput, but they're not so good. Then we turn off things like hyperthreading, because that again can slow down the actual clock speed. We turn on performance modes so that we don't get lots of ramping up and down of CPU speeds. We adjust various BIOS optimizations. Then on top of that, you have to have exactly the right version of Linux. On top of that, you have to have exactly the right version of Docker. And then there are things you have to do to the host itself to optimize that to that environment. One of those of which is to generate this MACVLAN networking. So your machine that is running a host operating system of Linux has a number of network cards. And typically those would have one MAC address and they would do one thing. Or you can build a bridge which would allow you to intelligently share that. What we use in these broadcast networks to allow multicast traffic to work is called a MACVLAN. So you're probably familiar with a MAC address. That's that hexadecimal address that you see, which is actually sort of the hardware ID of your network card. Well, what a MACVLAN does is it creates a software network as a driver on top of a physical network interface that allows you to attach multiple MAC addresses, essentially one per, we would call them application, you would call them container. So each container you start on top of that host operating system, when it gets allocated that physical port's network, gets assigned dynamically a MAC address, and then that MAC address can have its own IP address, and then it's able to actually appear as if it has its own network card, which means it can be addressed on its own IP address, and it can behave nicely alongside the rest of the stuff that's running on your network. But that's a boringly complicated thing to set up, and there's an awful lot that can go wrong. So what we did with the virtual rack is say, hey, don't worry about the chips, don't worry about the operating system, don't worry about those optimizations. They're baked into the cake. And then when you turn it on, just tell us, how many NICs you want us to turn on, what you want to do with them, give us an IP address, and then we will make that MACVLAN for you. We'll set up the software bridges. We will configure all that stuff in the background. But there are fabulous technologies there, and they are super powerful in just the same way that multicast and everything that Steve Church looked inside of Cisco and said, this is it. This is the technology that broadcast needs and wants. You just don't know it yet because it's written in the syntax of IT and it's solving an IT problem. But he had the vision to say that is exactly essentially what we're trying to build with TDM and digital switching and routing for audio. They've done it. It's at scale and at really good cost. Well, if you squint a bit and you look at all this Linux stuff, you get that same epiphany and you say, this is exactly what we want to need to make our stuff, cost effective, scalable, resilient, secure, and all these wonderful things. But you do have to squint a bit and you have to get every semicolon in the right place and you have to get everything in. So we thought, at least for the first few years of doing this, why not offer as a product an environment which actually orchestrates this stuff really efficiently and effectively for broadcasters, and lets us get up and running and lets us learn in a nice, safe environment, and doesn't antagonize the IT department by adjusting the BIOS on the main enterprise server, which is running the whole of the rest of their IT, just to make an extra 100 nanosecond difference to the latency time for our broadcast software.
You really encapsulate that so well. The first time I was setting one of these up, I felt overwhelmed with these technologies that are pretty normal for IT people setting up Docker containers, but not normal for me. And you're right. I had to take several swings at the ball to even connect the first time. Once I did, things got going. I couldn't tell you that I could duplicate it again without 3 or 4 more swings at them. Oh yeah, that's how you do this. And then learning it on different hardware platforms could be confusing too. There's a lot of sensible things to letting you guys figure this out and having a standard platform or a platform that you know how to deal with, and just let all that happen under the hood. It's a bit like if you'd buy an Omnia processor back literally 20 years ago, we didn't leave it up to you, the engineer, to figure out which diodes to put where, and which capacitors to put where, and which ICs and transistors to put where. No, we figured that out for you. You had to turn it on, and then you got to adjust the parameters to your liking. Well, that's very, very similar to what you guys are doing. You figured out all the hard stuff that I don't need to know day in and day out, or maybe even ever. I get to turn it on, tell it what I want to do. Of course, license the things that I tell it I want to do, because that's somebody else's property. And then off I go with either a whole radio station or a good part of a radio station in this appliance that you've made. I think that's just absolutely brilliant. Chris Tarr, I know you came in late. Have you got any questions for Dan here before we go to break, our last break?
No, I'm just soaking it all in. This is great. This is the kind of stuff that I'm just starting to get into.
Yeah, I can see myself implementing several of these and not having to worry and sweat. I just built up several servers for our stations in Mississippi, and I spent a lot of hours getting these servers tweaked exactly right. And we have not installed the Docker containers yet. Now I know that'll go well. I've done it before. I've had my colleagues do it before, but I've already put 15, 20 hours into just getting them all ready with the right OS. Some were Windows, some were Linux, but I certainly have spent some time and charged for it. So, wow, I'm really looking forward to we're going to have a final word from Dan here in just a minute. We got to take our last quick break. And Chris Tarr is here. Chris, you and I have a great friend in Mike Dosh. He's got this company, Angry Audio, and lo and behold, he's coming out with, you tell him, okay? You tell him what he's coming out with.
Let me tell you about this. It is fantastic. He has got a brand new broadcast mixer called the Rave. Now, a lot of people are now working from home, maybe, voice tracking or doing production, and you're faced with like these Mackie mixers. They all work, but they don't have the broadcast features that you need. And, there are some other smaller mixers that are fairly expensive. This one has all the features, everything you need, except the price is much more reasonable. Take a look at some of these features. They've got preview on every input. They've got different buses 1 through 4. They've got mix minus built in, along with mix minus with talkback. And if you look at the back, it's all Studio Hub ins and outs. And the power supply is built in. I'll tell you what, one of the reasons I'm here in Reedsburg today is we have another small console from another manufacturer that has a wallboard that is bad. So I had to order one, I had to go pick it up, and now I'm getting ready to install it. This is all, his famous power supplies there built into the console itself. It's got phantom power, it's got on-air tallies, it does the speaker muting, which is a big one if you're using Mackies, you're trying to talk on the mic. There's no mic muting there. This one has that. It's got powered headphone jacks, everything you need in a small, compact mixer. Perfect for voice tracking at home, for doing production at home, or if you're a small station, maybe you're looking for something for a production studio or on the air. This console would be a great fit for that. And it's so reasonably priced. And there's another thing coming out with the Rave. I won't tell you about that now. It's coming soon. It's a podcasting package that includes the Rave, and it sounds like it's going to be fantastic. Just one of the great innovations from our friend Catfish over at angryaudio.com. When things get sticky, get angry. Just get angry. Just go on their website, and they have the solutions for your problems. But check out the Rave if you're at home doing voice tracking, or maybe you're in the market for a new console. You don't need anything that big, but you want all of the features of the big boys. You're going to get it in the Rave. Check it out at angryaudio.com or any of your favorite broadcast dealers.
Thanks a lot, Chris, and thanks to Angry Audio for sponsoring This Week in Radio Tech. We're also brought to you by Max Connect. And you know what, Suncast, don't play the video. I'm not going to play the Gary Morrill video. I just want to tell you, I got to spend some time with Josh Bone last weekend. Josh got married, and I got to go to his reception, little party afterwards, and hang out with Josh and his friends. And I got to tell you, the Max Connect group, his company, is really growing. And I want to make sure you know that as engineers, sometimes we need help. We just don't have enough hours in the day. We don't have enough hands. We don't have enough legs. We don't have enough brains to go and do all the different projects that need to get done. And Max Connect Group, they've got people in a number of states now, mostly Eastern U.S., happy to travel for projects, but mostly Eastern U.S. If you need repairs done on equipment, if you need some consulting done, hey, how do I get this done? Max Connect Group is there as consultants, but they're also there as hands and feet on the ground to get projects done. You need to wire up a new remote control system at a transmitter site. Maybe you've got multiple transmitters. Maybe the current remote control setup is a mess and it's not well documented and you're not sure where everything is, and it's just not worth your time to figure out. Max Connect, that's just one example. They can come in, they can install transmitters. They're going to be soon having a tower crew available, so they can provide not only high quality consulting services, but also high quality tower services. So this is a company that's really growing. By the way, they're sometimes looking for new employees to take on expanded roles in the company. And that means engineers, perhaps like you and me. So I would really suggest you check these guys out, either to help you with a project, to buy some equipment that you might need, especially like Max Connect wireless services, and also if you need on-site consulting, hands-on engineering, Max Connect Group will absolutely get that done for you. Love these guys. Check them out. And thanks so much, Josh Bone and Max Connect, for sponsoring This Week in Radio Tech. All right, we've got just a couple remaining moments with Dan McQuillin. Dan, I'm sure you've got words of wisdom for us. As a broadcast engineer myself, I'm excited about this idea. What should I walk away knowing and thinking about the virtual rack product?
I just know that if you've been container curious but a little bit put off by some of the complexity, then help is coming. We get up every morning and we have put hundreds, probably now thousands of hours into understanding and solving and resolving all of these questions and concerns. We're going to invest that time and money back into the industry, along with Telos and others, to make this technology easier and easier. But I think if you really want to start thinking about it, then hopefully Virtual Rack gives you that opportunity to say, yes, I wasn't looking for a hobby. I have a day job, but I have some problems, and I think I understand now how this technology, wrapped in this way as a solution rather than a series of new and different problems and challenges of having to learn all this stuff, can provide that opportunity to move, from curiosity to action quickly and safely, without having then the concerns of trying to manage something with all the uncertainty that goes with it, that one semicolon in the wrong place, and with Linux you can sometimes be right back to the beginning. So I think our industry is facing a fantastic future as we're able to leverage these new technologies. I think it will allow us to provide the agility and flexibility and scalability that we need to do to meet all the commercial challenges that we face as an industry. The technology is there. We just have to kind of master it, and hopefully Telos have done the hard, low-level work of building these fantastic and really, really efficient applications. We've just done the easy bit of saying, I think we just need to actually wrap some conceptual structures around that, wrap an actual solution around that, and become a product. Whereas before, perhaps it was a technology and a hobby more than a product.
Yeah, well, I know what you mean. And some of we could talk a lot more about Linux being a very professional product, but also a very hobby product. You kind of got to be into it to make it walk and talk. So thank goodness for you guys, for your R&D people, your developers, to do that walking and talking under the hood, so that I can turn it on and look like a genius for making these broadcast appliances, these broadcast applications work in my favor. So thanks a lot. I look forward to implementing Virtual Rack at one of my radio stations in the near future myself, and I mean that. I'm looking forward to getting that done. Chris Tarr, you got a last word for us? Oh, what? Me? What?
There we go. Now I got it. Had to figure that out. No, the only funny last word is I was on my way here to the Reedsburg radio station, and I forgot that earlier I think it was last fall in the winter, the tower fell here, and this is out in the middle of nowhere, and it's an AM tower. I've got a long wire now. We've got an STA, but I'm driving out of town, and I almost drove right past because I'm so used to seeing that red and white tower sticking out of the ground. It's not there anymore as a landmark. So I'm thinking about that. I'm like, how many other people are missing their turns and things because that tower isn't there anymore? It's been there for 60 years or whatever, and now it's gone, and people are just lost because there's no reference point anywhere.
How do you get to the reservoir? Well, you turn down there where that old tower used to be.
Yeah, right, exactly. Like, that was the conversation, I think, when it fell, was the owner called me and said, remember the tower we used to have in Reedsburg?
Oh, no. Well,
like, what are they used to?
When we can containerize a tower, Dan, there you go. Click on ERI,
Yep.
and how big a tower do you want to license? Wouldn't that be something?
Exactly. Call me when that happens.
We solved that. In the UK, most of our transmission is done by a company called Arqiva, and so we are very ignorant of that sort of stuff because most of the RF engineering, is not done by the in-house engineers. So yes, I am always incredibly impressed by US radio engineers, that when you go and visit a US radio station, there's at least a 50% chance they're out at the tower dealing with some sort of fire or something. And I go to NAB and I see all this stuff that looks like plumbing, and I have no idea what that is. So I might know where to put the semicolons in a virtual rack. But yeah, if I went to a transmission site, I would probably kill myself. Yes, because I would, touch the wrong thing. So yeah, you guys are, a hat tip to US radio engineers who are proper RF radio engineers. The rest of the world, we kind of outsource that, and we just walk around with a laptop feeling smug.
By the way, we're going to help our listeners feel smug. We're going to have links to the show notes, including links to the virtual racks. You can find out more information about it. Dan has done some videos, some interviews about virtual rack. We'll have links for those also in the show notes. So look in your TWiRT This Week in Radio Tech show notes. We got to go right now. Suncast is about to hit me over the head with an exit sign, so we got to go. Dan McQuillin, thank you for being with us. Chris Tarr, thank you for joining us. Good to see both of you. I appreciate it. We'll be back next week with another This Week in Radio Tech, and thank you, Suncast, for producing another wonderful show. I really appreciate it. See you next week. Bye-bye.